receipt. This in my pocket. My phone randomly decided to play a video. Sorry about that. All right. So before we get started, I'd like to acknowledge the Field Museum resides on the ancestral homelands of the Ojibwe, Odawa, and Potawatomi. This area was also a site of trade, gathering, and healing for more than a dozen other Native tribes. So today is not only an armor seminar, but it's also the Field Museum's Women in Science sponsored seminar speaker. And so I also hope that many of you are attending our Women in Science mixer and panel discussion this evening in the East Atrium. And if you're not, you should. It's my pleasure to introduce today's speaker, Dr. Emily Taylor. Emily is currently a professor at Cal Polytech, where she's the director of the Physiological Ecology of Reptiles Lab. And she simultaneously runs a snake removal business on the side, which really helps prevent conflict between people and rattlesnakes around California. And there's a lot of rattlesnakes. Emily's going to talk all about them. Emily attended UC Berkeley as an undergrad, where her passion for museums and reptiles was first sparked. And she did a PhD at Arizona State University, which is basically the land of rattlesnakes, which Emily, again, is a real expert on. Along with over 60 publications, Emily's accomplishments include advising dozens and dozens of students over the years, publishing books, and being a recent past president of the American Society of Ichthyology and Herpetology. Emily and I have known each other for well over a decade, probably more like 15 years at this point. We've been on a bunch of committees together, and I can say it is always a good time when you get to interact with Emily. So without further ado, I'd like to introduce our speaker today.
Thank you, Sarah, and thank you so much for inviting me. I'm so thrilled to be here. This is my third visit to the Field Museum. The first time was as a graduate student. I didn't know anyone in the museum, so I was only just, looking at Sue the T-Rex. The second time was on my first sabbatical when I was at St. Xavier University down in South side Chicago. I still didn't know anyone, so this is so wonderful to have an opportunity to be here and to be able to see behind the scenes and to meet some of you. So I'm excited to talk to you today about spying on snakes with secret cameras, which is my new obsession. Most of my research, as Sarah said, has been in snake physiology, but you're not going to hear much of that today. You might hear some physiology adjacent stuff, but mostly this is about something that I'm calling next generation natural history in honor of the fact that we're here at a natural history museum, which is where I got my start. And now the research that I do is basically just natural history with a interesting technological twist, which is the secret cameras. So I didn't make up the term next generation natural history. There was this really cool paper a few years ago that talked about it. And they basically identified three things that are important to this concept of next generation natural history. The first one was leveraging this for ecological theory, conservation, and management. And that's, of course, was really important for me because over the years, I've become much more interested in conservation applications of my research because my students have been too. The more and more students are interested in making sure that they're doing work that really matters to them. And that's conservation where I come in. Also, it can connect more people with nature. And so this is important in the part of my work that deals with outreach and community science, which is mostly what I'll be talking about today. And then, of course, in training the next generation of ecologists. So I am at a master's granting institution. It's a primarily undergraduate institution, and student mentoring is the focus of what we do. So everything we are evaluated on, and the whole reason we're there is for student research and for teaching. And so for these reasons, this was really important to me. They talked about in this paper about all of the ways that we can use technology-fueled innovation. So many of these you recognize, things like drones and satellites and telemetry and fancy cameras. And so the fancy cameras is a lot of what you're going to hear about today. So rattlesnakes are really my main research animal, kind of my muse. As you'll hear today, I have a lot of connections with them on scientific levels and on other levels as well. They're incredible study animals, and they're also one of the most maligned and persecuted animals, unrightfully. And so symbolically to me, they really stand out as an underdog and something that if we can try to change people's minds about rattlesnakes, it really shows strategies for making people care more about anything that's maligned or any type of unpopular organism. So just briefly, some background, especially for the benefit of the students in here, my obsession with rattlesnakes. evolved through 3 different places. The first was where I got my bachelor's of English at UC Berkeley, and it was the Museum of Vertebrate Zoology that turned me into a scientist. So I started out my life as a scientist in a museum, which is why I'm so in love with museums, and of course, with natural history. I did my very first project on the Baja California rattlesnake by cutting open museum specimens to look at what they ate. I also got to do field work with prairie rattlesnakes, which is cool because that's what you're going to be hearing about today. My very first rattlesnake field work was there with prairie rattlesnakes. I look a little terrified handling my first rattlesnake there at age 20. And then I went on to Arizona State, like Sarah told you, where I did physiology research, learned how to become a physiologist under the tutelage of Dr. Dale DiNardo, who's there watching me with a big Western Diamondback. And then finally started my own lab in 2005 at Cal Poly, which is a engineering and technology school. So this is a STEM-focused school. Lots of opportunities for people who like to build things and do really cool things that can benefit my research. And so, of course, a lot of this natural history work that all of us in this room do is really important nowadays because you can basically insert any organism into this. You know, the insect apocalypse, right? The decline of birds, and of course, it's happening with reptiles too. And I would like to basically say that my niche in this is obviously conservation biology research, but it's also combating the negative imagery that we see coming from other places that are really trying to, doing unfortunately, a good job of displacing some of the good work we do. So one of those I like to call the Animal Planet effect, which is true of some poor natural history programming that we see on things like Animal Planet, Discovery Channel. Also, YouTube is a big one. I should probably start calling it the YouTube effect now, honestly, because it's a lot of unscrupulous YouTubers are really portraying snakes in a negative light, making them seem really, really scary. To the point where it has really major consequences. So obviously, rattlesnake roundups were around for a long time. They've been around a lot longer than this. But this really helps to reinforce this stereotype of these snakes as terrible animals. And I mean, if you don't know, of course, rattlesnakes are rounded up by the thousands, are poorly treated. And then these are the kind of things that really bother me. Children can, for $10, can buy a rattlesnake and they can skin it alive and then dip their hands in the blood and put it on a wall and sign their little names next to it. And so to me, this is really symbolic of us raising a generation of kids, not just with nature deficit disorder, but like, this is sadistic, right? I mean, this is a good way to raise sociopaths. And so a lot of what we do is to really try to reverse that as best we can by showing animals behaving in the way that they actually do, not like this. So with that, my history, kind of combining my natural history, physiology, and engineering and technology training, I'm just going to show you a few vignettes of how I've used technology to kind of change the way that we do a type of natural history study. And most of that is going to be on camera technology coming up. But first, I wanted to tell you about this, which has been one of my favorite little technological advances in my whole career. So right at the beginning, when I was a grad student, was when these eye buttons, if you haven't heard of them, were coming onto the scene. And I love this because a bunch of snake scientists were like, okay, they've developed these miniature data loggers to put in produce trucks that were going across the country so they could see whether the produce had been exposed to high or low temperatures. Let's put it inside animals, which is what physiologists did. So of course, that's what we do. When we do radio telemetry on rattlesnakes, which are big enough animals to put the radio transmitter in there, we also would put these little plasti dipped eye buttons, which would be programmed to take body temperature at any given time. And we did this all the time when we were doing other work. So we just knew that someday maybe this body temperature data would prove important. And sure enough, it has. One of my grad students came to my lab and we had 10 years worth of data from a bunch of different populations. And it resulted in this paper, which is the first vignette I'm going to tell you about. My graduate student, Haley Crowell, who's now a PhD student at University of Michigan, did this really cool study where she used the body temperature data that we had from a bunch of different populations of Western rattlesnakes, shown here, to model the energy budgets of these rattlesnakes. And she showed that how resilient they will be to climate change. So in fact, rattlesnakes where we live are projected to do well with climate change. So just briefly, let me tell you the story of how this works. This is the California Central Coast where I come from. And we had done 4 longish term studies, 2 inland where it's really warm. As you can see on the top right there, the temperatures get really warm at the inland sites and they're much more mild at the coastal sites. And we had these data from the eye buttons where we radio tracked snakes for a long time. And of course showed that that translated into the body temperatures of the snakes being higher at the 2 inland sites than at the 2 coastal sites. And there's much more to this paper, right? We were doing a thermal ecology study and looking at how climate change would impact them. But today, for fun, I wanted to focus in on one particular thing, which is that we were able to quantify how many of these guys, which are California ground squirrels, the favorite food of these rattlesnakes, that they would basically need to survive. And so the way we did this was to plug our iButton temperature data and the snake's mass into proven, equations that are ground truth in the lab on their standard metabolic rate. So what we're doing is we're saying, how much energy do these snakes need per year in the form of ground squirrels? We had to figure out the caloric content of a ground squirrel. That was fun. Later. And this is not to, females need more to reproduce and stuff. This is just like a male rattlesnake just to live. So quiz time, first of all. This shows you at the different sites here, the number of ground squirrels that they would need, average size, so 1 meter long, Northern Pacific rattlesnake, just to not lose any weight. So yell out some numbers. What do y'all think? You're biologists too, so you're probably gonna be a lot closer than when I give public talks. Yell out some numbers. How many do they need per year? 6, 4, 10, 50? Do I have any Price is Right fans in the house? $1 would have gotten you there. So it's less than 1. So these animals are true, magicians of low energy. If you look at the standard metabolic rates of snakes, which are of course as ectotherms much lower than endotherms, rattlesnakes as ambush foragers are still an order of magnitude lower than that. So turns out that a ground squirrel is about 690 calories, which is about half of a Chipotle burrito if you load it up with sour cream and guacamole. And that's all they need. Now, of course, they will and do eat more, which is important for growth and for long distance movement and for females making babies. But that was a really cool study that we did. Incidentally, we're now working with, we got every single scientist in the country who has long-term iButton data to send it all to us. So we're modeling energy budgets of snakes all over the country with an undergraduate project right now. It's very exciting. But now on to cameras. So the next thing came out of a study that we started with my colleague Scott Boback in Colorado, which was this. This is a snake mega den. They're prairie rattlesnakes, where you walk up and you see literally hundreds of rattlesnakes gathered at these places that we call rookeries, meaning that the pregnant females all stay at the den on the hills. They all bask together. These are all pregnant females. And they give birth in these big communal nesting sites called rookeries. Now, I want you to notice what these snakes are doing as I've walked up there in person with my cell phone camera. They're rattling at me. They're terrified, right? They're not behaving naturally. They're really freaked out, okay? Now, let me tell you a little bit about prairie rattlesnakes as we look at these. This is at a high elevation site in Colorado. So they spend most of the year underground, hibernating deep underneath the ground, under the snow. And in the spring, they pop up, they bask for a while, and then the non-pregnant females, the ones that are too skinny that year, and the males, they all go down into the prairie and they hunt all summer long, while the pregnant ones stay behind here and bask and have their babies together all summer long. And then the males and the non-pregnant females come back in the fall, they all bask together, they go down. So we were doing a thermal ecology study on these animals. So this was actually in the middle of the pandemic, the beginning of the pandemic. We put a bunch of iButtons and radio transmitters in the snakes, as you can see there. And then we did this thermal ecology study where we put out operative temperature models that you can see in the middle there. That long pipe-like thing is an operative temperature model of a snake. And this is at a rookery right there. So the cameras, hold that thought because I'm going to come back to those cameras in just a minute. So just briefly from this study that we just published recently, one thing that we discovered by doing this research was that the rookeries, by staying at the rookeries as opposed to going down the hill, it allows the snakes to have more accurate thermoregulation, which means that they thermoregulated closer to their preferred body temperature. So we actually measured their preferred body temperatures and gradients, et cetera. And what we found is that by putting out these models in both exposed, so out in the middle of the sun, which is the red line, and also in the shade of the oak trees under the blue line, that if you look at the rookery site, we actually have, let's see if I can show you this. Right here is where you really want to look, is that it stays warmer at night in the rookeries. And that allows them to have a better thermal quality of the environment, which means that the pregnant females basically got to stay closer to their desired temperature. So thermoregulatory accuracy is a comparison of the snake's preferred body temperature and their actual body temperature they achieve. So 0 right there is like a perfect line where the snakes were perfectly accurate. They were able to thermoregulate right at their preferred body temperature. And if they go down from that, it's because they got too cold. And what you see is that the pregnant rattlesnakes are able to stay closer to that preferred body temperature. So that's one reason why they stay at these rocky rookeries, probably the rocks, right? They maintain heat at night. I mean, this was all very obvious to us. We just had to show it mathematically. Like we knew why they were going to stay there. We had to show it. And so what you get is you get these mass aggregations of female rattlesnakes, at least in part due to thermal reasons and probably other reasons. But the result is incredible social interactions that you see. So of course, while we're doing this, we put those cameras up. And these are time-lapse cameras that just took pictures every 5 minutes. And we thought, oh, how fun. We're going to set these up, leave and go back to me, California, my collaborator, Pennsylvania. This again is in Colorado. And we'll come back in the fall and we'll collect it and we'll learn everything about what these snakes are doing socially. As soon as you leave, by the way, this is what you get. They all come out. You can see the operative temperature model there in the middle. And those pregnant females are just all over it all the time. And we were all smug and proud of ourselves for our methods. And then we realized we had tens of thousands of images and we didn't know how to go through them. And AI does not do well with snakes that are curled around one another. So we resorted to, and resorted sounds terrible because it sounds like it's a last resort, is amazing. Zooniverse. If you've never checked this out, you should. It's basically the world's biggest community science website. And as of 2019, we started in 2020. It has over 2 million now registered users. And this was actually really complicated to make this project. We had to make, a field guide, communication forums, all kinds of things. But essentially, people come on and they will code your photos for you. And this was how Project Rattlecam was born. And I'm going to be talking to you the rest of today about Project Rattlecam, my favorite kind of intersection of research and community science and outreach that we've done to date, and of course, technology. So we started with the Zooniverse project where people would code these photos. So a photo would pop up and they had are there snakes present? Yes, no. I'm not going to go through all the methods of this where we had a lot of quality control built in, really complicated, but it was amazing is what it was. We had 3 different rookeries at 3 cameras per rookery. Basically, it ended up being over 60,000 photos to analyze. And of course, they were analyzed the retirement limit by 10 different people each time. So this is just a massive number of people looking at these photos. And I did the calculations and it would have taken me, if I did it from like 9 to 5, it would have taken me 5 years to go through them all myself and doing nothing else. And instead it took 267 days for the public to do this. And we all know the benefit of this, right? It wasn't just that it made it easier for me, it was that the public was doing science on rattlesnakes and seeing rattlesnakes behaving naturally. The mothers taking care of the babies. Is that what they're doing? Things like that. And so here's some of our quick research questions. And again, feel free to ask me more about this later. But as you'll see, I want to spend most of the talk talking about kind of Project Rattlecam 2.0, which is coming up. So we asked how many snakes are at the den. So at this particular den, we first went up and caught a bunch of them, and we put a unique color code in each of their rattles. We caught 375 of them. This is how many, and then we go up there and let them go, and most of them still didn't have colored rattles. The place is insane. So we think at this particular den that there's probably about 2,000 rattlesnakes coming and going from this spot that's about the size of half of a tennis court. Insane. How did they get water was amazing. So we get these photos back. The second it starts raining, and you'll see more of this later, the rattlesnakes do something that turns out the public finds adorable, which is always what I'm looking for, right? Which is they curl up and they flatten their bodies down and they make themselves into little teacups and they drink the rain off their back, which is cool because if you think about those pregnant females who are at the rookeries, they don't go down the hill to get to water. That's their only water for that whole summer long is this rainwater. And the brand new babies will do it too. They'll drink off of each other. It's incredible. And of course, what preys on the rattlesnakes? So we got to see all kinds of images. It's mostly birds, mostly red-tailed hawks will come down and grab those snakes. So these are just some of the things that we were doing with that Zooniverse output on the Project Rattlecam. And all in all, when we looked at everything that happened at the end, we had over 6,000 people. So 6,300 different people spent time coding photos about rattlesnakes. This was very exciting to me. It was my first major foray into community science. And what I saw was all the chatter about it on Twitter. People loved it and people thought the rattlesnakes were cute, right? This person was cooing over the babies gallery. Apparently baby rattlesnakes are really cute. And so this was a cue to me that this was a really good outreach method, right? Can we get this kind of thing to more people? And I had a conversation about this with my undergraduate mentor, Dr. Harry Green. And he said this to me. He said, absolutely, Emily, just get people out there. If people were out there showing wild rattlesnakes doing their thing, it would blow their mind. In other words, if we can avoid seeing the BS on YouTube and the Animal Planet showing like terrified rattlesnakes, you know? If people can see them doing their natural thing, they would be blown away. We all know what the problem with that is, right? If you take a crowd of people to where there's rattlesnakes, the people will scare the rattlesnakes, like I showed you with the rattlesnakes that were rattling, or someone tells a friend, and someone comes out there and either collects all the snakes or, you know, shotgun shells we find there all the time, that kind of stuff. So you can't really take people to the snakes. We all know that. So instead, we decided, well, it was really fun taking the snakes to people with Zooniverse, but what's even better than Zooniverse, right? What's even better than time-lapse images? And this is where we're getting now into probably the thing I've been most excited about in my entire scientific career. Was I was thinking about this that summer, and I was thinking about as I was watching my very favorite live cam on the Cal Falcon cam, which is on the Campanile at UC Berkeley, my alma mater, where you get to watch the peregrine falcon parents like feed their babies and things. And I thought, you know what, there's bird cams everywhere. Why don't we have a snake cam? That would be amazing to have a live cam, because it was really my hypothesis that when people could watch it live, they would feel like they're a part of the action. They're not watching something that took place last year. They're watching something that's taking place now. And could that be really transformative to people's opinion about rattlesnakes? And also it was because I just wanted an excuse to be able to watch rattlesnakes 24 hours a day at home. So this comes into the last and the longest part of my talk, which is how we created the first ever live streaming camera on a rattlesnake den, and the one in Colorado, using the just really incredible camera technology, because I thought it was gonna be really easy. I'm like, all right, let's call the bird people and find out what they do. Well, you know what they did? They plugged into the power at UC Berkeley on campus, and they used the Wi-Fi. That's really easy, but doing it in remote areas is actually really hard, it turns out. But luckily, I am at Cal Poly, where I'm surrounded by engineers who can build anything, and build anything they did. These are my two graduate students, Owen and Max, showing the guts of the camera that we ended up installing in Colorado. So the bottom left, you can see it's all the custom-built relays that were made by our engineers. Underneath that, in this big insulated box, are the weatherproof batteries that will not be ruined by being under snow for 5 months of the year. And then Max on the right is holding the camera, which is a remotely operated camera. Here's how it works. This is the system where they are, it's attached to the rocks there on the snake den. It is a high-end security cam that you can remotely pan, tilt, and zoom. So I can be sitting on my laptop anywhere in the world, and I can be chatting with people on YouTube, and they'll say, will you zoom in on that snake over there? And I can just zoom right in for them. So you're really making the people feel like they're a part of it. And in fact, I'm gonna say this now so I don't forget later on. I spent a lot of time watching live cams out there. There's cool ones where you can watch, bears fishing for salmon, all kinds of stuff. The one thing that most of those are lacking is a highly moderated chat. And that's because it's really hard and involves a lot of energy, but we did it because we thought it was really important that we were there to answer questions. And so what we created was one of the first live cams where we had it fully moderated for 12 hours a day for 5 months. My students all coordinated and did it, where people could ask questions and talk about rattlesnakes and learn about rattlesnakes in that moderated chat, and ask the camera operator to do stuff so they felt like they were in control. It was all solar powered, and we had a Verizon unlimited data plan, which is not easy to come by. Ask me later if you're curious. And of course, it streams to YouTube 24/7. We also had a Davis Instruments cellular weather station so that we could see the weather all day long. And in fact, it was linked. So on the caption of YouTube, the people could check in and find out the temperature at any given moment. So here's some installation shots. Really big solar array there. It's a 4x8 foot panel we had to install. And you can see how difficult, right, it was, all the stuff we had to take up there. And you can see it's cold too, right? We did this in the beginning of spring. It was like early May of this year, when the temperature is really volatile there, let's just say. Because we were there for 5 days, and 2 of the days this happened. And then, after this for a day, you'd go up there in your winter boots and you'd look down and there's a patch of sun and there's a giant pile of rattlesnakes starting to come out for the year. So a truly amazing place at that time of year. And this is what we get. So the rest of the talk, I'm going to show you videos of rattlesnakes, folks. Okay. So I wanted to just talk about the astoundingly crisp image quality that we attained. Like, I still can't believe it to this day how amazing it is. Here's a typical pile of female rattlesnakes that we would see. In the top left, you can see the date. So this one was May 29th. It's about 6 p.m. and the snakes would be out basking in that evening sun. Now, watching what that snake's doing with that jerking behavior, Does anybody think they might know what that is? When do when do rattlesnakes jerk their heads on other ones? Does anybody know? Well, it's a courtship behavior that we see males do on females, but that's a female who's doing it on another female. So in the beginning, I said, well, what's going on? Like I would walk up to, with my binoculars and watch bunches of snakes before, and I'd be like, oh, that's a male courting a female. But we've been watching these snakes, so we knew that they were all females at this point. What on earth is going on? I'm gonna come back to that later. This is sped up, but look at how many snakes there are, right? So just huge numbers of snakes would come out basking. And you can see that's because it's all sped up like 8 times, so it's pretty fast, but you can see us panning out with the camera to be able to watch them. These are all pregnant females, like I said, basking. And while we're watching this incredible footage, which I love so much, I will tell you that I have 2 grad students, Owen and Max, who you saw in the photo, who are actually doing their master's by collecting data off of this. So in addition to this outreach tool, one of them is studying thermoregulation. So he has operative temperature models out there. He has the weather station. He's interested in how UV radiation at high altitude dens can actually impact their basking behavior. So he has all that he needs from this live cam. It's going fast because it's sped up. The other one is studying their social behavior. Look, there's a garter snake coming out, okay? So garter snakes co-overwinter with these snakes. So this was in July. Normally, all the garter snakes have left for the year, and they've gone down the hill to where there's wetlands, where they're hunting and even gestating. This is a very pregnant female garter snake. We got all excited, like maybe she would stay and, give birth to her babies along with the rattlesnakes. We never saw any baby garter snakes, though, unfortunately. Okay, this is a close-up of it zoomed in. And I just want you to say, like, we were sitting here watching this, and we're just marveling. We are watching live a rattlesnake slowly breathing, but in the front, you can see its heartbeat as the body goes up and down. Like the idea of that to me was pretty incredible, right? That we could sit there in our sofas or in our laptops, or for me, it was always my second monitor that's supposed to be for spreadsheets, was always on the snake cam. And we can be seeing things like this. And of course, these snakes don't know that they're being filmed. So we're seeing their actual behaviors. Side note here is we had a group of 2 high school students who studied their respiratory rates all summer long and who were doing a study on how their respiratory rates change as a function of temperature. Drinking. So this is so much better than seeing it on snapshots. This is sped up as well of a thirsty snake drinking from her coils as the rain came. So this only happened a few times because turns out this is a very dry area of Colorado. So the snakes would come out and just greedily drink for hours whenever we had a light rainstorm. They would drink off of themselves, drink off of each other, and we discovered that people went nuts for this. People would start telling their friends, and all of a sudden the chat would like quintuple in size because everyone would come when the snakes were drinking. So snake drinking off of themselves is a good outreach tool we really learned. Here's another one of a baby rattlesnake. So I'm kind of jumping around in time. This is in September 4th here, which is this would be less than a week old baby, comes out, and watch how it responds to its very first rain of its life. Curls right up like a cinnamon roll. So you can see our camera now. This is not sped up. This is real time. And it starts drinking off of itself. Look at the flattening of the body. So it's all instinctive. And this is something that I assumed that it was instinctive, but we didn't really know until we started the live cam. But these babies instinctively know. They come out dehydrated already from their moms, and they instinctively know how to drink. So we're going to watch as this goes on because, again, even in early September, the weather here is very volatile. So you can have things like a nice little rainstorm where the baby's getting tons of water turn to hail rapidly. So let's watch this little baby as he's getting his first drink and maybe getting a rude awakening too. I like this part because now there's like a big pool. I'm like, oh yeah, he's got lots of water. Just chugging it. Ah! I got him right in the noggin. So now it decided to go down and it hid underground, right? So look at these crazy hailstorms. We also saw there were some times when it started as hail and then the snakes would go and hide and then they would come out and start drinking from the melting hail too. Okay, so you saw the head jerking earlier that we saw. Well, by watching these snakes and by learning their individual personalities, which I'll talk about in a moment, that's something that we could do is we could identify individual snakes. We realized that these snakes have a secret language. I think I have to press go on this one here. And remember, snakes don't have good hearing. They have inner ears, but no external ears. So they can't really hear. They have amazing chemosensory abilities, but they also have decent vision up close. And so they talk to each other with these head jerks. So that's a pregnant female talking to a brand new baby. It's not her baby because she's still pregnant. What are they saying? We don't know. Keep watching. Here comes another baby. Baby's doing it too. Oh, bumps them off. So the babies also are born with this just instinctive ability, and they do the chatter. We call it Twitch chat, where they're clearly chatting with one another. The babies are doing it too. What are they saying? I don't know, but I'm dying to try to decode it. That's unfortunately out of my skill set right now. I don't know how to decode rattlesnake secret language, but we have, literally unbroken since early May, 24/7 footage of these snakes with lots of examples of them doing that. What are their predators? Of course, we were curious to see. And when you're watching them all 24/7, you get to see sometimes what their predators are. This is a magpie. Lots of snakes in the back. They're freaking out about the magpie being there for good reason. And we're able to see how the magpie handles that snake. It grabs it by the head so it doesn't get bit, and off it went. Magpies are, this is just a replay of it here, just looping. Magpies are apparently major predators of baby rattlesnakes. However, I will say that this was the only predation event that we saw and confirmed the entire summer long on this site. By the way, I should say this isn't the same site as the one where we caught the snakes and did the rattle colors. That's a different site. So these snakes have never been caught. It's all completely remotely done. And why? It could be, safety in numbers, right? It could be that these birds don't come very often because they're terrified of getting bitten by an adult snake. I don't know. But we thought it was going to happen way more often than it actually did. Okay, so fun stuff. It turns out that it wasn't just pregnant females. A few males hung around the rookery. And here's what happens when there's a pile of pregnant females under there. Here's what happens when two males see each other. Any of you who know rattlesnakes might know that it's kind of like a coveted interaction to be able to witness in the field, which is a ritualized combat between male rattlesnakes, where they don't bite each other, but they kind of stand up, so to speak, and wrestle. And again, I want you to all imagine you're watching this live with people who don't know that rattlesnakes, what they do. And they're like, what is going on here? And they just, behavior after behavior, felt so privileged and so much more interested in what was going on because they were watching it live. And as we're watching this, I want you to be thinking about it. Like, what is the point of this? Okay, so male rattlesnakes tend to exhibit this ritualized combat over access to females. So usually it's happening when, there's a solitary female, you're not in these den situations, and this is not sped up, that's normal speed. And the winning male will win. So the losing male will crawl away, go underground, and sulk for a couple weeks. His cortisol levels spike, corticosterone levels spike. And the male rattlesnake is all hopped up in testosterone, and he goes back and tries to mate with the female. Well, this male rattlesnake in the front there, the winner, his name is Thor. And he provided a lot of inspiration to people on this. He was very interesting. We're going to talk about Thor some more. And again, you can see how we're moving the camera to follow it. It's just like better than TV, right? Okay. All right, so how was this a community science project? Well, one thing was that viewers could name snakes. And so we taught them how, we had directions on how they could use the unique patterns of each snake to be able to identify the snake. So they had to find the same snake on 3 separate days and take screenshots and describe the pattern to us by outlining it in color. So all those different ones are outlined in color there. And then they would submit it. And if we said it was legit, they could name the snake and they would get like an adoption certificate and a sticker in the mail. And they also, on our website, you can go and you can click on them, and they submitted things like what the snake likes to do for fun, like, you know, walks on the beach, that kind of stuff. So it was really fun to do that. And you can see Thor on the bottom right down there. Thor was definitely the most infamous snake because while a lot of the viewers were on this, they were on here constantly and they got really good. They're like, oh, that's Mandy. Oh, that's Linda. Thor was the one that was really obvious the entire summer long. And the reason was that early on, Thor got bit by an ant on his lip. And we watched this happen. We watched this snake. There's actually a clip called a rattlesnake with an ant lip ring, because it was on him all day long. It latched on and it was biting him all day long. And 4 months later, Thor still has a dramatically swollen lip, his bottom right there. That one was just taken recently. So he was really obvious to ID because of that swollen lip. I think that's really cool, just natural history observation too, that his mouth was impacted by these ants. And Thor did all kinds of fun things. Thor was a total Casanova. He was constantly courting the ladies. And I want to point out, these are pregnant snakes. And before we started doing this, and I've asked a ton of rattlesnake biologists, have never really seen male rattlesnakes courting pregnant females. And so some people would say, well, why would you do that? It's a terrible idea because they can't get pregnant. Well, rattlesnakes are interesting. Rattlesnakes, like many other snakes, can actually store sperm for extended periods of time, even years possibly. So maybe it would be worth it if you could get them to mate with him, but we never saw a female accept. We never saw him accept. Interestingly, we saw 3 instances of Thor dramatically courting other males. And is it true courtship? I'm not sure, right? Oftentimes when we see same-sex sexual behavior among animals, we try to explain it away, right? As like, oh, it's a mistaken identity because of pheromones or something. I don't know. Or, you know, is it a dominance display? I honestly don't know. But this is a male right here. Thor is the one with the striped tail there that's following him. And he did this 3 different times on 3 different males. Full-on head jerking, tail wrapping, very serious courtship from very unwilling males. Or male rattlesnakes don't like to be courted. And while this was all happening, a colleague wrote me and said, I just saw 2 black-tailed rattlesnakes, one courting another one. It was males. And so just all of a sudden, we saw this evidence for same-sex sexual behavior in rattlesnakes. I'm going to fast forward this one so you can see some of the tail wrapping behavior better. So you can see him, he followed him in there and just sat there with him for hours and hours and hours, just tail wrapping, okay? So again, we saw that 3 times, which is pretty amazing.
All right, you guys, listen up.
Listen.
This is not a place this is not for you. Get your tail out of my face. This is not a place for you. This is a place for rattlesnake. Look over here. These are rattles. You don't have them. You don't belong. Stop that. Get your tail off of me. Stop. God, oh, rattlesnakes. Just, you're joking me. Stop it. Stop. Get off of me. Oh. Stop it! Stop! Okay, just you. Oh. Oh, I hate garter snakes. Oh, this is no. I'm out. I'm out. This is nonsense. Oh, don't respect. I'm 4 times your size. This is nonsense. I could totally bite you. I got venom. I got real venom, not that rear fang crap that you have. Oh. No, don't go up there. Don't. They're animals. Those guys are complete jerks. Oh, hate garter snakes. They're the worst. Hate them.
Okay, so first of all, 3 cheers to my husband, who's in the back row right here, who's the narrator there. So the antics between the garter snakes and the rattlesnakes were fascinating, right? The garter snakes in the spring had these giant mating balls. And of course, as you saw there, sometimes the rattlesnakes got in the middle of it. But again, people really loved watching this. And we found that people were just shocked that garter snakes and rattlesnakes would be together. We got hundreds, probably thousands of questions from viewers. Are they going to eat each other? Are they going to eat each other? And we're like, no, neither of them eat other snakes. And they were just shocked that they could coexist. I thought this was really interesting. The concept of people just being amazed that two types of organisms like that could coexist together, but they totally do for the most part. I mean, we made it look like that snake was annoyed. Maybe he was a little annoyed, but for the most part, they just sat in each other and ignored each other. Okay, I said 24/7, right? Camera has night vision, so watch what happens when it turns to IR, okay? So the night vision was incredible. You just saw the change at dusk. And it turns out that the camera was trained on the rocks where we could zoom right into this crevice where the snakes would pack in at night. So during the active season, we could watch snakes all night long as well. So do you guys see these little flies that are buzzing around on those snakes? So I don't know anything about flies. This is just going to keep looping. I don't know anything about flies. And so I said on Twitter, what are these flies? Or I thought they were mosquitoes at first, honestly. And someone said, I think they're forward flies. Turns out, no, they're not forward flies. They're, oh my God, I always forget this name. I'm going to remember it in just a second. Starts with a, oh, darn it. I'll think of it in just a second. But they are a type of fly that is, it's a type of sand fly. If anybody knows it, holler. And they're blood feeders. However, these are all males. And we figured this out because someone was watching. They said, friend of a friend of a friend is this fly biologist who studies these kind of flies. Do you love when this kind of stuff happens? And so he started watching and he like basically freaked out because he said, we catch these flies in fly traps all the time. We study them in the lab all the time. The females are blood feeders and these males are probably like on these snakes waiting for the females to come feed. And then the males will mate with the females, but we never have seen them feeding in the wild. They never knew what the flies feed on, et cetera. And so I put this out there and then all of a sudden, all these other snake biologists sent photos in of these flies, which I'm so irritated at myself for not remembering the name of it. They are phlebotomides, and there was a subgroup of that too. But anyway, yeah, sorry, and look it up. All of this other of speckled rattlesnakes, sidewinders, northern Pacific rattlesnakes, of these same kinds of flies, different species of that same group, all feeding on these snakes. So it's not to say that they're specializing on the snakes, but that we've really discovered this cool behavior. And there was times when there was just clouds of them. We finally did see females coming in and feeding and being mated by males. So it was just a really cool other natural history experience. Okay, and then best of all, we saw live birth on camera. This is sped up a little bit. It's like sped up 2 times. So we watched, no one had ever seen rattlesnakes give birth in the wild. And we were watching it live at like 10 o'clock at night with people, just pushing out babies. And this was a really incredible moment as the video went on. So rattlesnake babies are born inside an amniotic sac. Cave crickets would come and they would eat all of the amniotic sacs, umbilicus, drink all the fluids afterwards. So they're born in an amniotic sac and then they have to punch their way out to take their first breath because their umbilical cords break, so they're no longer getting oxygen from the mother. So in a couple minutes, you'll see some of that footage of baby rattlesnake taking its first breath. So watch in the bottom and the middle right there, head out, first breath. And again, I can't express how amazing this was to be watching this live with a bunch of people from around the globe. And it actually, because it was 10 o'clock at night, it was people from around the globe. This was a really cool story because the same mom moved and she just decided to go right in front of us. I'm going to raise my tail and show you it right out in the open. And this was a particularly amazing one because this baby comes out and this was her 8th baby. And we had watched baby after baby after baby come out of its umbilical, come out of its amniotic sac, take a breath. This one didn't for a while. This one sat there. I was zooming in there. You can see like some of the blood vessels there in the amniotic sac. And it was weird because she had moved. She gave birth to like 8 babies and then she moved somewhere else and the baby came out. And it just sat there and people started, the crickets came up, started chewing on it. people started freaking out, the viewers. They're like, oh my God, is it stillborn? Is it stillborn? And by this time it was almost 11 at night. I was tired. I had to go to work the next day. And I'm like, I don't know. So there's the umbilical cord. So I thought, the umbilical cord's still attached, still getting oxygen, right? Hours passed. I zoomed it out and went to bed. There's the baby right there. I zoomed it out and I was like, I don't know what's going to happen, people. And then meanwhile, the chat went crazy. Watch. Do you see? Look, there it is. It eventually emerged from its sac. And it was the hypothesis of the community science viewers that the cave crickets chewing on the amniotic sac is what allowed that baby to get out of its amniotic sac. I don't know if it's true, but it was their hypothesis. So they started calling the cave crickets the doulas of the world. So anyway, this was really fun because people have been really worried, and it was a very dramatic night. Okay, so all is said and done, just from this one spring, we had over 2.5 million views, 15,000 subscribers on YouTube, 200,000 watch hours, and we got major international news attention in 2 cycles, when the camera first went up and then when the babies were born. I think the most crazy interview I did was a live breakfast show in New Zealand. So people were really interested, as they are, in snakes. We had the stream publicly streaming all day long in 7 zoos and hopefully counting. And it would be so cool if they were at natural history museums too. Screen. And so a lot of people got to see this. And we did a survey at the end of it for people, and we asked them to write something about, what the stream meant to them. This is just a word cloud of that. Of course, lots of different things on here, but the biggest word that came out was love. Like they say, I love seeing this. I love watching this. And here's just a few examples of things that we saw. I went from being fearful and not a fan to embracing them as an important part of life. It changed my misconceptions of them. They are much more social and gentle than I realized. So the social behavior was a big part of this. I used to watch an abject horror, and now I watch because I like them. So lots of things like this. Of course, we had people who are already snake fans watching too, but tons of folks watched who hated rattlesnakes, and it changed their minds. It was really amazing. We also developed a curriculum called Rattle Ed for grades 3 to 5. This is Joy and Ariel. They're teachers in training at Cal Poly, and they developed this really cool curriculum where the kids will have a science notebook and they watch the live stream for a little while each day and they collect data on it. They design their own experiment. And we also are studying this. So we have an IRB approved study where beforehand, if you look at the bottom, the students have to draw a picture of a rattlesnake. They have to say how they feel about a rattlesnake, and then they have to do a little smiley face thing, like, how am I feeling today about rattlesnakes? So it's a way, instead of a survey, it's like a kid level survey. We do that before and after the curriculum to use that as a method to test the hypothesis that this curriculum might improve the kids' ideas about rattlesnakes. I should say here too, that this curriculum is also built in with very much like rattlesnake safety. Like, we don't go up to and pick up rattlesnakes too. Like, it's not like Rattlesnake Love Fest, right? It's very practical. All right, so what's next? Like I said, we have 2 graduate student projects from this year that they're working on right now. And they have actually invited the longtime viewers, community scientists, to help them go back and code a lot of these videos that they've taken throughout the winter. We're integrating Rattle Ed into schools now, grades 3 to 5, so that we can test that hypothesis about kids changing their minds about rattlesnakes. Continuing the Colorado CAM in 2025, and then very exciting, we just made the announcement a couple days ago, we have a Pennsylvania CAM on timber rattlesnakes starting in 2026, so which will be really cool because this is a very different type of snake than the prairie rattlesnakes. So if I have my way, I'll have these CAMs all over country, different aggregations of rattlesnakes that we can watch. I didn't even mention it, but we have a California CAM too, that we've been watching snakes there. There's the Pennsylvania CAM. Won't that be awesome to look at those beautiful timber rattlesnakes all day long? All right, so this is a montage of baby rattlesnakes yawning. As I say thank you to my main collaborator, Scott Boback, and of course, tons of students and volunteers who've made this possible. And the entire thing, almost the entire thing was donor funded, because this truly is a project that's for people. So it's funded by people. And we're already halfway through fundraising for the Timber Pennsylvania CAM, and we haven't even really started trying yet. It's really amazing. People are into this project. And so it's just a great combination of outreach and science, and just like I said, an excuse to be able to watch snake TV all day long. So thank you very much for listening, and I would love to take any questions now. And that's just gonna keep looping. So you can keep watching yawning snakes while I do questions.
Now
Any
it's on.
questions?
If anyone has a question, raise your hand and one of us will bring a microphone over.
By the way, those are brand new babies. That's the mom, and they're like hours old.
They're so cute.
Question?
Awesome talk, Emily. I'm going to have a question that should be focused on the rattlesnakes, but I guess it's not. How are you going to archive those data, do you think, over time?
Yeah, it's a really great question. So first of all, we have done the California cam for 4 years now, but it's just not very exciting. So that's why I showed you the Colorado cam. There's only a few snakes there. Colorado was amazing. So each one is archived on YouTube. What we did was we set it up so it has two 11-hour and 45-minute recordings every day, and it would turn off for 15 minutes as it archived that section, because on YouTube you can only archive up to 12 hours. And it would turn on again. So all footage except for those two 15-minute sections for Colorado are permanently archived there. And now my students are going back and they're using a new like voice annotation program to be able to go through that, which I think they're wishing they had started from the beginning now. But so that they can annotate those. We also in Colorado did something from the very beginning, which is every half an hour on the half an hour, we took 4 snapshots. We would move the camera to preset positions and do 4 snapshots. And so that, like, for example, my student who's doing the thermoregulation study, he's using those archived snapshots to go back and collect data on the exposure of the snakes, the postures, et cetera. In the long term, I think we're going to continue doing that and hope that YouTube will continue giving us gigs and gigs and gigs and gigs and gigs of data, just like Verizon somehow allowed us to just stream like gigs of data every day. It was crazy how much we were using. So that's what we're doing right now. Other questions?
Yep, here I come.
So I'm from Pennsylvania, so I'm just curious what region of Pennsylvania the camera would be in, where timber rattlesnakes are.
Yeah,
Thank you.
thanks. Central Pennsylvania. So I went out there a few weeks ago to meet with a collaborator out there, and we toured a bunch of, we're going to put it, so timber rattlesnakes tend to overwinter den in different places than they have their summer basking rookery sites. So we're going to put it on a summer rookery site. And we found several that were good. At Central Pennsylvania, oh my gosh, it's so remote. Like I flew into Pittsburgh and then I took an hour-long commuter hopper flight into a smaller town and then drove hours. It's just like one of the remotest places I've been in the country. There's very little cell service. So you have to have cell, but we found a few spots that have good service. And so we're still thinking about which one to use, but we found a few good spots. The thing about timber rattlesnakes is there's hundreds of spots where they do those gestation sites. And there's smaller numbers of snakes at each one, as opposed to the prairie rattlesnakes where there's hundreds or thousands all in just a few spots. I'm excited. I don't know very much about timber rattlesnakes. I've only done Western rattlesnake biology, so I'm excited to learn about them.
Hello, this talk was amazing. I could not stop smiling. It was super cool. One question that I had, so I've had experience watching like common terns of bird in their like nest sites. And one thing that I saw a lot of was competition between the chicks and like those interactions. And so I was curious if you were able to observe any of that on here, or if most of the social interactions were like parent to baby or parent to parent.
That is a really good question. And this is the kind of thing I'm interested in. You can imagine, like, as a physiologist getting into behavior. I don't know if any of you are behavioral ecologists or if you know behavioral ecologists. It's another world, right? It's different to learn how things are done. And there's a lot of interesting argument over what it means to be social. Like some people think that you have to be doing it to be social, but I'm like, well, if it's because of temperature or water and they're all together now and they interact and they talk to each other, like they're social. I don't know. Anyway, no, there was no antagonistic interaction seen ever among anyone except for those couple males I fought like twice. None of the babies ever had any antagonistic interactions. And I think I know why. I think it's because the parents aren't feeding them like they are with, I think that with the birds you're talking about, they're fighting over food, right? Is that the case?
Or space sometimes.
Yeah, the right spot. Yeah, so I think there's probably plenty of both of those things. So here's a fun fact about baby rattlesnakes. A lot of people, and many of you might know this already, if some of you are hurt people. people who would watch the camera are like, well, how do they eat? Are the parents feeding the babies? Because the parents would just hang out with the babies or just, protect them. If a bird came by, they would kind of scoop them in. There is parental care, but it's not feeding, like, or is it? So the cool thing about what they do is that right before they're born, there's still a bunch of yolk left in that amniotic sac, and the babies will suck the yolk into their bodies. And then when they're born, the umbilical cord falls off. They have this cute little belly button. And we had a couple times when we were doing research on them, we would have like a stillborn or a baby that died right after birth. You open them up, there's a huge yolk, like this huge yolk sac. So they take it with them, and it's like the parents pack up the lunch sack, the yolk sack, for them to go on their way. So they did in fact feed them, and they live off that yolk sack for a long time. So those baby rattlesnakes don't get a meal before they go down. By the way, if any of you are watching this, wanting to watch this at rattlecam.org, they're just going down to hibernation right now. Like in the middle of the day, there might be a couple of snakes out, but it's just the end of the season right now. They haven't eaten, those babies haven't eaten, and they won't eat until next summer. And another cool fact is the pregnant females who gave birth this year, they'll eat next summer, and they haven't eaten since 2 summers before, like last summer. So the last time they ate was last summer, they didn't eat this summer, and they'll eat next summer. 2 years in between feedings for these female rattlesnakes. Totally crazy. Yeah. So no antagonistic behavior. Just a lot of curling up together. That's probably for thermal reasons, probably for avoiding water loss across their skin, and then probably for social reasons. So one of my grad students, the old data that has all of the coded rattle colors, he's building social networks between those known snakes, and we have DNA samples for those snakes. So we're going to be looking to see if the snakes like spend more time hanging out with snakes that they're closely related to. Lots of things to come from all of this.
We probably have time for one more question.
One more right here in the front.
I was wondering about how you found the rookeries and what makes a good rookery. Like, what do the rattlesnakes look for in a place to congregate like that?
Yeah, great question about the rookeries. So in a lot of places, well, first of all, we found them from like a friend of a friend of a friend kind of thing. My colleague, Scott Boback, had gone there for a couple of years. It was a high school friend's property or something. It's on private land. But people could just find them by looking at like Google Earth and finding like rocky outcrops in isolated prairie around them. There's lots of these throughout, the plain states. So in places like California, for the most part, they don't den up like that. They'll just go individually into a squirrel burrow because it's a mild winter. Places that have really gnarly winters, the snakes are more likely to come together in these big dens. And that's probably because there's only a few of them that have the thermal characteristics that are important for overwintering, and also, as we showed, for the rookeries in the summer. So what makes a good snake den in this area is there are volcanic peaks that have a bunch of fissures that go deep down. My colleague brought a ground penetrating radar up there and showed really complex. It's not like a big cave under there where people think the snakes are all together in. It's like all these different crevices and cracks that go way down. The snakes just wedge themselves in there down there. That allow them to get down below the frost line, because this is an area of Colorado where there's snow, like it snowed a couple nights ago. There's snow from mid-October through early May. And we had the eye buttons in them over the winter, and we showed that their body temperatures stay at around 1 degree Celsius. So they're really just defending that almost not quite frozen thing. And then just one cool fact for the end here. Our study that we're doing right now with the energetic modeling is showing that extended winter that they have, where they're in that kind of like diapause, is actually what is contributing to the fact that they can reproduce so frequently, because they have no energy expenditure. So you know how I told you it was the male rattlesnakes in California need like less than 1 ground squirrel? Well, we calculated what's needed for the pregnant females and non-pregnant females in terms of wood rats, because that's what they eat in Colorado. And it was a third of a wood rat is what a non-pregnant female needs, and like 2/3 of one is what a pregnant female needs. Again, not to make the babies, but just to sit there with them, for the year that they're pregnant. Really crazy stuff. So thanks.
Awesome. That was so great, Emily. And thank you so much.
Thank you. Thanks, folks. This was fun.